All right, let's get started with section 6.3 regarding medians and altitudes of triangles. Our objectives are to use medians and find the centroids of triangles, also to use altitudes and find the orthocenters of triangles. So our essential question is, what conjectures can you make about the medians and altitudes of a triangle? All right, let's get familiar with some key vocabulary words. So take a moment, pause the video, capture the definition of a median, which is a segment from the vertex of an angle to the midpoint of the opposite side. So this segment from the vertex to the midpoint of the opposite side is called a median. All right, let's use the information we just learned about a median to solve for x. So if segment CD is a median of triangle ABC, then find x. So we know that a median goes from the vertex to the midpoint of a segment. So that makes segment AD and segment DB congruent. All right, so if BD equals AD, then we can substitute 6x plus 7 equals 4x plus 11. Solve for x by subtracting 4x from both sides. Combining like terms to get 2x plus 7 equals 11. Subtract 7 from both sides. All right, 2x equals 4. Divide both sides by 2, so x equals 2. Now let's talk about the centroid, another vocabulary word. It is the point of concurrency of the three medians of a triangle. Again, our medians go from the vertex to the midpoint, vertex to the midpoint, vertex to the midpoint. So our three medians all intersect at a common point called the centroid. Additional properties that the centroid has is that it's the center of gravity of the triangle. Also, it is 2/3 the distance from the vertex to the midpoint. So if we were to put some letters in for the unknown lengths, let's take a look at this median. So if the length distance is 2/3, then you have 2 parts plus 1 part, making it a total part 3 parts. So because this is unknown, we put the x. So 1x plus 2x gives you a total of 3x. So this is going to be your longer part of the median that's worth 2/3 of the whole. And then from the centroid to the midpoint is 1 part, therefore 1/3 of the whole. And that's true for all medians. We have different letters because we have different medians. But it's 2 parts plus 1 part, which is a total of 3 parts. So that leads us to the centroid theorem. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So in this picture, the medians of triangle ABC meet at a point P, which is the centroid, and that means that the length of AP is 2/3 of the length of A to E. The length of BP is 2/3 the length of BF, and CP is 2/3 of the length of CD. All right, here are the instructions for constructing and finding the centroid of a triangle. So you can try to follow these steps on your own. I will provide a video that helps explain these steps at a later date. All right, let's take a look at example 1. You're using the centroid of a triangle to help find lengths and measurements. So if we know that medians hit at a midpoint and we know that the properties are such that part of the median is 2/3 and the other part is 1/3. Let's use that information in triangle RST. Point Q is the centroid and SQ equals 8. So find the length of QW and SW. So we know that SQ, this longer part of the entire median, is worth 2/3 of the entire median, which is S to W. So if that's true, we can write out a little formula. And then we substitute for SQ the 8 value that we're given, and then we solve from here. So I need to multiply both sides by the reciprocal of 2/3, which is 3/2. So 3/2 gets multiplied on both sides, resulting in a length of SW is 12. So then QW is equal to SW, the full length, minus what we're given, which is 8. So 12 minus 8, which is 4. So this little portion is a length of 4, and the full length is 12. All right, now you try one on your own and see how you do. So pause the video, try, and then unpause the video to check your answers. All right, did you get a length of RQ being 10 and RV equaling 15? Let's check. So we know that from Q to V is 5, and the full length is going to be RV of the median. Well, this little portion right here is the smaller part of the entire median, which makes it the 1/3 measurement. So to find R to Q and R to V, we would need to plug it into the formula. All right, so if 1/3 is 5, then 2/3, I would double that 5, and that's how I get 10, and then add the 10 and the 5 to get 15. All right, so for this one, let's use the information we know and properties that we know about the centroid, which is that a centroid goes from the vertex to the midpoint. So we're going to find the coordinates of the centroid of triangle RST with the vertices at R21, S58, and T83. So first step always is to graph your triangle with those vertices. Once you kind of have a visual of your triangle, then you're going to use the midpoint formula to find the midpoint V of segment RT. And then step 3 would be you can find the centroid because it's 2/3 of the distance from the vertex to the midpoint. So and we can see that this is on a vertical line. So those are easy lines to figure out distance because all you have to do is just count. So this is a distance of 6. So 2/3 of 6, which is 4. So you go 4 units down. There's your centroid. So your centroid is located at 5, 4. All right, now you try these. Pause the video. Find the coordinates of the centroid of the following triangles, and then unpause the video after you've tried them on your own to see if you're correct. All right, here's your solution to number 4. So pause the video, jot down, make some corrections to the work that you did, and see, maybe check to see what errors you made. And then here's the solution to number 5. So pause the video, check over all this information, see if your work matches this work, and if it doesn't, make corrections. And if you have additional questions, please bring those to class tomorrow. All right, let's talk about the altitudes of triangles. The altitude is the perpendicular, super important, perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. So for an acute triangle, that's easy. Here's your vertex, and then just go perpendicular to the opposite side. That's an altitude. And it's on the inside. For a right triangle, an altitude is one of the legs. So it's on the triangle. For an obtuse, it's on the outside. Because from the vertex perpendicular to the side would have to be on the outside. So what you have to do is extend this side. That's why we have a dashed segment here. And then you can get the perpendicular. So your 3 types of triangles, take a note of where the altitudes occur. And then here's what we know about the concurrency points of the 3 altitudes of a triangle. It's called an orthocenter, In the acute triangle, the orthocenter is on the inside of the triangle, as you can see in this picture here. In an obtuse triangle, the orthocenter is on the outside, as you can see here. And then in a right triangle, the orthocenter is on the triangle, and it's actually where it is a right angle. So the lines containing AF, BD, and CE for each of our pictures meet at the orthocenter called P of triangle ABC. All right, let's take a look at example 3, finding the orthocenter when it's in a grid. Again, step 1, graph your triangle with those vertices given. Then because the altitude is perpendicular, so find an equation of the line that contains the altitude from Y to segment XZ. And because XZ is horizontal, the altitude is vertical. That's so that you have a perpendicular line. The line that contains the altitude passing through at -2, 4. Sorry, so the line that contains the altitude passes through the point -2, 4. So the equation of the line is x equals -2. Step 3, find the equation of the line that contains the altitude from x to segment YZ. And this would require you actually calculating the slope because it's going at a diagonal. So the slope of line YZ would be -1. Now, because the product of the slopes of two perpendicular lines must be -1, the slope of a line perpendicular to YZ is +1. So the line passes through at -5, -1. So we plug in all these numbers that we have to get the equation in the y equals mx plus b form. So after you substitute the numbers that you're given, so we have an x and a y, and we have a slope. So plug in all those numbers in the y, m, and x positions according to the values that you figured out. Solve for b. Now that we have b, which is your y-intercept, plug that back into your slope-intercept form, and our slope was +1. So we've got y equals +1x, which we don't see the +1, plus the 4y-intercept. Now step 4, find the point of intersection of the graphs of the equations x equals -2 and y equals x plus 4. So this requires you substituting x, -2, into your equation to solve for y. When you do that, you get y equals 2. So the coordinates of the orthocenter are at -2, 2. It's definitely a lot of steps, but just try one on your own. And then our final example is example 4, where we have a proof. So again, just take some time to try to understand the logic of a proof and how it flows. Take what you're given, mark up the picture if you have to, or take the marks and make some conclusions. And you're ultimately trying to prove in this one that segment BD is an altitude of triangle ABC. So for this style, I chose the paragraph proof. And essentially, you always start with your givens in the sentence. And then from that given, what can you conclude next? From the next statement, what can you conclude next? And then from the next statement, what can you and so it just flows logically. If this is true, then that is true. If this is true, then that is true. Until you get to the end where you have the final conclusion, which matches what you're trying to prove. So take time to study this proof and come in with additional questions to clarify. So you might be asking, how am I supposed to memorize which segments make which special points? So all along, I've been giving you the mnemonics to kind of help you. So put it all together and you've got an odd peanut butter cup may contain apple butter instead. Here's our list. So for our two new ones, you can say altitudes orthocenter, so an odd. We already did the perpendicular bisector circumcenter with the peanut butter cup mnemonic. And then the new one, median centroid, may contain. And then previously we had angle bisector incenter, which goes with apple butter instead. So here's our phrase, our mnemonic phrase to help us remember all of these. The end.